You know those giant metal towers you see dotting the landscape, especially in a long road trip? Well, those are electrical pylons, and they are, no joke, absolute marvels of engineering. Today, we're going to dive deep, take them apart piece by piece, figuratively, of course, and really figure out what makes them tick. So let's get right into it.
Okay, so right off the bat, here's the central challenge, the big puzzle engineers have to solve. How on earth do you build a tower that's super tall and pretty slender, but at the same time strong enough to handle literally anything nature can throw at it? I mean, think about it. It's got to hold up these heavy power lines for miles and miles. So how do they actually pull that off? Let's dig in and investigate.
All right, so here's our mission for this explainer. We're going to understand these pylons so well that by the end, you'll feel like you could design one yourself. Seriously, we're going to put on our engineer hats and really tackle this from the ground up. Okay, first principles. Every single structure out there, I don't care if it's a massive skyscraper or the chair you're sitting on right now, it really only has one main job: support a load without breaking. And part of that load is, well, its own weight. Get that right, and you've got a stable structure. And that brings us right to the star of our show today, the pylon. So what is it, really? It's a special kind of frame structure, and its whole purpose in life is to support those super heavy power lines over huge distances. These things are literally the backbone of our entire electrical grid. Okay, so we've got the what down, but now for the really cool part. How does it do it? I mean, you look at it and it's this kind of delicate-looking lattice of steel. How does that stay standing through a storm? Well, this is where the real engineering magic, the secret sauce, comes in. Let's break down the secrets to its amazing strength. Just imagine what these pylons have to put up with. They are in a constant battle with the elements. We're talking gale force winds, mountains of heavy snow, the blistering sun, you name it. And through all of that, they absolutely cannot fail. That means the design has to be pretty much perfect. So, what's the first secret weapon in an engineer's toolkit for this? It's called cross-bracing. You see all those X shapes that make up the pylon? Yeah, those aren't just for decoration. They are absolutely crucial for fighting off sideways forces. You know, like the wind trying to push it over. That X is what gives it stability.
And what does cross-bracing do? It creates triangles. And let me tell you, triangles are basically the magic superhero shape of structural engineering. Why? Because they are incredibly rigid. Think about it. You can easily squish a square out of shape, right? But you can't do that to a triangle. It holds its form. That's why you see them everywhere, from bridges to bike frames to, you guessed it, pylons. Let's just walk through this. Imagine you have a simple square frame. It's kind of wobbly, right? You could easily push it over. But watch what happens when you add just one diagonal beam. Boom. You've just created two triangles. And suddenly it's way, way stiffer. Now, add the second diagonal to make that X shape. You've got four triangles, and that frame is now rock solid. That, my friends, is the awesome power of triangulation. Okay, so we've got our secret weapons: cross-bracing and triangulation. Simple enough, right? Well, not so fast. Just because we know the principles doesn't mean there's only one way to build a pylon. In the real world, engineering is all about making choices, and every single choice involves trade-offs. There's just no such thing as one single perfect design. So, have you ever noticed how pylons can look really different from each other? There's a simple reason for that. Form follows function. The design of a pylon that has to cross a massive river is going to be totally different from one that's squeezed into a busy city. It all comes down to what specific job it needs to do. Yeah, let's look at a classic comparison. On one hand, you've got the steel lattice pylon. That's the one we've been talking about, built on the genius of triangulation. It's super strong, but also relatively lightweight and efficient with its materials. Then, on the other hand, you might see a solid concrete pole. Its strength comes from just sheer, solid mass. Both of them get the job done, but they come with a totally different set of pros and cons, especially when you start talking about cost, materials, and, importantly, what they look like. And that last point, what they look like, brings us to something that's actually really, really important, something that goes way beyond just the mechanics. See, great engineering isn't just about making sure things don't fall down. It's also about thinking how these creations fit into our world, into our lives. And let's be honest, for a lot of people, these pylons are just ugly. They see them as a scar on a beautiful landscape. And that's a massive factor that any good designer has to think about. And it's not just about whether they're pretty or not. Pylons can also pose real safety risks, especially if they're near places where people live or where kids might be playing. So a truly great design has to think about everything, Not just the physics, but also the people who have to live and work in the shadow of these massive structures.
All right, we've covered a lot of ground here. We've looked at what they do, the forces they fight, the brilliant engineering principles that keep them standing, and the real-world problems they create. We've got all the essential intel. So now it's time for you to put on that engineering hat. It's your turn to get ready to design. So, let's recap. Here's your design blueprint, the key takeaways you need to remember. First, whatever you build, it's got to be stable and it's got to last. Second, you have to harness the incredible power of cross-bracing and triangulation. Third, remember that every design has pros and cons. You have to embrace the trade-offs. And finally, and this is a big one, you must always think about the visual and safety impacts on people and the environment. So that's it. The ball is in your court now. You've got the engineering principles down, you understand the problems and the trade-offs. So the big question is, what will your pylon design be all about? Are you going to prioritize maximum strength above all else? Or maybe low cost is the most important thing? Or will you focus on creating something that has less of a visual impact? The choice is all yours. Now go design something amazing.